Hello, my name is Reed Burton, and I am currently working on a project that will allow for threat detection utilizing a turtlebot. This robot would be able to simultaneously localize and map its surroundings in an unknown area, identify threats using facial recognition, and navigate to the threat to simulate engaging with the enemy. High-value target identification should be quick, efficient, and risk-adverse in order to make fast-acting and accurate decisions under pressure while minimizing risk to civilian or friendly forces. The issue with current identification methods is that it oftentimes requires soldiers being physically present to both identify and eliminate a high-value target. This causes much risk and can lead to miscalculations and errors in judgment. In order to improve upon this issue, I propose the use of an autonomous system that can identify, navigate, and eliminate a threat without the need for risk of unnecessary human life. Utilizing a slightly altered design, the turtlebot will accomplish the task using a package called Face Recognition and an object tracking package called Multi-Object Tracking LiDAR, which when combined can identify objects and pair them with detected threats using the face detector, which the turtlebot can then navigate towards. After spending a large amount of time working on this project, it became apparent that the goal to have a threat detecting robot, the way I had originally envisioned it, was not realistic. Throughout the process, I was plagued with issues varying from packaging compatibility, insufficient computing power, and a simple lack of time to understand and implement the several new packages and concepts needed to complete my goal. However, this did not stop me from learning and accomplishing a large amount, and although incomplete, this project provides a basis for future growth in threat detection and only scratches the surface of its possibilities. My first achievement for this project was successfully setting up the most important feature of threat detection, the facial recognition. This required creating a brand new Linux environment capable of running numerous required packages for the face recognition code. This meant reinstalling ROS from scratch and working through the troubleshooting involved with that process. Upon completion of that task, the next focus moved on to testing the face recognition package. Upon more troubleshooting, I was able to run the code in a Python script that recognized faces from a webcam video input. This showed that a known face can be recognized as a threat in Python and used to detect specific individuals out of a group of faces. The most important aspect of threat detection was accomplished, and now this needed to be implemented into ROS. This is the point where the majority of the issues were met. In order to create a scenario for a turtlebot to detect threats in, a simulated environment was needed. This meant creating a new gazebo world with modeled threats that the facial recognition software could detect. The major issue faced is that Gazebo ran very poorly on the issued cadet laptops, and any complex models would cause Gazebo to crash immediately due to a lack of memory. This meant that pre-made worlds with rooms could not be used, and any human-shaped models often led to issues. The first issue was overcome through the use of a very simple world simulation with blocks representing people that could be detected by the turtlebot. The next issue faced was incompatibilities between several ROS packages and facial detection software. The face recognition code ran on Python 3, whereas ROS ran solely on Python 2. This led to an issue with running face recognition in a ROS node, where both cannot run simultaneously. I did not have time to learn a new facial recognition software and implement it into my design, so this was a major issue that I could not overcome. Individually, the facial recognition worked, and so did the ROS simulation, but combining the two was not possible at the time. If I were to improve upon this project in the future, I would work with a different face recognition software compatible with Python 2 to allow for the use in ROS, and spend more time working through the incompatibilities between programs. I would then at this point have implemented the multiple object tracking LiDAR ROS package, and use the facial recognition to detect a threat, output an angle from the camera using OpenCV, and pairing this data with the closest detected object and navigating to its position, successfully completing the project. Unfortunately, the project was not completed, but from this experience, much can be taken away about robotics and threat detection as a whole. Also, with some extra time, coding, and working towards a solution, a very usable product can be produced that can have real-world applications for the future. Thank you very much for an amazing class, and I believe that from the lessons learned in this course, I can accomplish great tasks in the field of robotics, and we can look forward to a better and brighter future.